Hi, welcome everyone for joining us tonight. It's just 6 o'clock and we'll make a start in a minute. I'll just wait for a co-host and Mark to join us. They're still busy, but I'll do a few introductions first. So this is the first in a series of webinars we're hosting this autumn, aimed at the sort of retrofit supply chain. So that's consultants, architects, contractors, etc. And we're really glad to be joined by Mark Siddal tonight to talk about energy efficiency standards and retrofit. So we'll give Mark a bit more of an introduction in a minute, but first I just want to do a little bit of housekeeping. So we are recording this session, just in case anyone wants to know before you ask, and we will put it on our website and that will be available for anyone to look at once we're finished. If you want to interact with us over the evening, you can use the chat box. So feel free to say hello in it. Often people accidentally don't use the drop down and just send a message to the panelists. So if you want to make sure that you're talking to everyone, make sure it's clicking all panelist attendees. I know that was a bit of an issue last time we had one of these sessions. So that's for sort of any issues you have with technology or for general comments. But if you want to ask any questions, if you pop your question into the Q&A box, so if you go to the bottom of your screen, you should see that there's a Q&A box. So click on that. So if you've got questions you want Mark to answer, we'll be taking questions at the end. Or if there's a specific question while he's talking, maybe say specific question to answer now as a preamble to your question, and then we'll interrupt Mark. He doesn't mind being interrupted as we go along occasionally. But if it's more sort of larger questions, then we'll take them at the end. Also, you can use the hands up button. I think it's on your participant box. So if you click participant, have a go now. And I can't see it as a host, but I believe you can raise your hand by clicking something in the participant box. So also feel free to do that. Yep, Jonathan has raised his hand to show that it is possible. So yeah, please use that. So that's the housekeeping done. So I'll just do a little bit more of an introduction to Carbon Co-op and People-Powered Retrofit. So myself and Liam are facilitating tonight from Carbon Co-op. Carbon Co-op's a community based in Greater Manchester who want to take practical action on climate change through supporting those within our co-op and those who aren't in the co-op to drastically reduce their energy use in their homes. We have quite a few different areas of work now around energy systems, around working with local authorities, but a big part of our work is around retrofit and supporting homeowners to reduce energy at home through retrofit. Over the last 18 months to 2 years, we've been working on a BEIS-funded project called People-Powered Retrofit, which I think some of you will be aware of. So essentially we're piloting an approach to building a local market for retrofit in Greater Manchester. That's through supporting the demand for retrofit, through engaging with householder clients, and also engaging with the supply chain. So that's architects, consultants, contractors of lots of different sizes, from sole traders to small firms, and sort of supporting supply to meet demand essentially. And our experience has been demand has been quite high, and we want to support the supply to really engage with that demand. So as a part of that, we're really looking to grow our connections to the supply chain. So if you do fit within that bracket of consultant, architect, contractor, Airtightness expert, and you haven't engaged with us yet, please fill our sign up form, and I will pop it in the chat box in a moment when I've stopped talking. So please click on that and sign up to hear more about what we do, and it might lead to potential sort of working with clients of ours in the future. I will stop talking soon, but just wanted to tell you about a few more things. So we've got a series of events this autumn. They're on our website, but I'll just talk you through a few now. We've at the end of September on the 28th, our colleague Marianne from EnerPHit is going to do a session on our home retrofit planner, which is our sort of home assessment tool using SAP methodology. She's going to give much more detail into the development of that tool and how we use it. So it's particularly useful if you're interested in potentially using that tool in the future. We'll be joined by EnerPHit in October to talk through some ventilation case studies. That's particularly useful for you know, housing association, local authority officers, and anyone interested in ventilation. Yeah, I'm really looking forward to that. In November, fingers crossed, we'll have our first people-powered retrofit client on site, and we'll be doing a virtual site visit to their house, talking with the contractor and having a look at the work they're doing there. So yeah, it's been a challenge thinking about how do we do these things virtually, but I think that should be a really interesting one. And then in December, we're being joined by Harry Paticus, who has done the first ever step-by-step passive house retrofit in the UK. He's going to tell us more about that. So you can find out all about this on our website and you can book. So that's enough about me. It would be really great for us to understand who you are. So I've got a few polls. If you don't mind, I'm going to launch them now. So if you can't see the poll, I've been told that you have to minimize Zoom in your browser apparently, and then the poll might show up. Is that right, Ian?
Yeah, it doesn't seem to be a hard and fast rule, but by and large it works. Just make it off full screen and it should turn up.
So feel free to vote. We've had a few votes come in. So we'll give you sort of 30 seconds or so to fill this out. Or maybe more actually, because there's 3 questions.
Need an exciting drum roll.
Yeah, or some music in the background. Had an ice cream van 5 minutes ago. But yeah. You've got about 50% of you voted, so we'll leave it another 20 seconds. I think I might end polling because it might just be that there's a glitch in the system that sort of says. Okay, so I will share results. So most people here, we've got a good big group of householders, lots of architects, some energy consultants, a few contractors and specialist contractors, other building professionals. I put that in there because I was sure I hadn't got all of the different types of people around, and other. In terms of retrofit, we've got a lot of people who still learning but know a fair bit, a few beginners and quite a few experts in the room, which is great. And most people work in domestic, which is perfect. Yeah, thanks very much for taking part in that poll. Right, so this is time for me to stop talking. I'll let Liam introduce Mark.
All right, well, yeah, hello everyone. So I've just got a brief introduction for Mark. He's a fellow trustee of the Association of Environment Conscious Building, and his architecture firm, Leap Architecture, have received numerous awards for energy efficient construction and such like. He's a technical advisor for the AECB Carbon Light Programme and the AECB Building Standard and the Passivhaus Trust. He was one of the pioneers actually of bringing the Passivhaus Standard into the UK in the first place, and has got a general deep interest in ecologically aware construction. He's also a regular contributor to Passivhaus Plus magazine and Green Building magazine. He co-authored the Certified Passivhaus Designer course, or you helped co-author it, and I have to say he's always immaculately turned out. So yeah, there we go. Mark, everyone.
Oh. Thanks, Liam. Okay, so yes, welcome everybody. I think, yeah, basically today's presentation is geared around setting retrofit standards. So for those of you that are quite well experienced, an expert, this will be kind of reaffirming, shall we say. There's no, no new rocket science or anything involved in this. I'm not really getting into any deep geekery or anything like that. So in terms of setting our standards, what do we need to think about? So really we're looking at the reasons to apply retrofit to projects, and it's not well, there's a whole host of different reasons, as we'll see. And one of the key things that I'd like to draw attention to during the course of the presentation is the contrast, shall we say, between a fragmented shallow retrofit versus a whole house deep retrofit. And most of the time, in fact virtually all the time, what we see in the industry at the moment is this shallow fragmented approach. Whereby people do a little bit here, a little bit there, and they're just sort of muddling along, and they don't really have a clear end goal in mind. And unfortunately, this has a real negative consequence, because it means that they could be making the quality of their environment worse rather than better. And it also means that they're locking themselves in, and financially, to scenarios which are far less than optimum, because it becomes too expensive to go back and try and fix everything. So I get different people contacting me at different points saying, "Can you come around and have a look around and tell me what I need to do to retrofit my home?" And you go in, and it's already a very, very nice house. It's in a very good state of repair. They've already spent a lot of time trying to get it habitable over the last 15 years. And ripping it apart is a real challenge, really challenging conversation to have in that sort of environment. Whole house deep retrofit means that we're taking a much longer term view, and we're planning things out from day one. And that means that we're being more conscious about our approach to things. And we'll talk about some of the methodologies that I apply in my practice to help with that towards the end. A bit about me, touching on a few things, as Liam said, somewhat ecologically motivated in terms of carbon emissions, and also the collapse of in biodiversity, and also ethically, as an architect, I feel that we've got to be closing performance gaps, because otherwise we're defrauding our clients. So we've got to really start to address issues there from a whole host of different ethical imperatives. This is kind of the generational story, should we say. We've got my folks there and my daughter, and that kind of gives me the incentive to kind of focus my attention on the next generation, which really leads us on to Greta, of course, and thinking about what we can do, as custodians, and how we can go on to try and address issues. And my view is that if you're aware of a problem, then it's our responsibility. So, as Greta says, I want you to act as if your house is on fire, but it is because it is. But it's not simply because of climate change, I'll hasten to say. There's a few other things going on that we need to be conscious of as well. So in terms of a bit of scene setting at a national level, we've got just over 20 million homes in the UK, and what we can see here is year one is now, for argument's sake, and we have time running ahead of us, 50 years or so there. And what we can see is that we've got a lot of building stock already, of various different age groups. Many dating, reasonable chunk dating before 1919, and then different intervals since, roughly breaking down in sort of 4 million home chunks. And then we've got new homes or new stock on top of that, which we'll be adding to the equation. But you can see there's also a general downwards trend on some of these older bars, on the older stock. And that's because of the replacement rate. We demolish homes as well, and so they're in a general state of decline to some extent, but not, as you can see, not a significant amount over time. So what that means is that at the moment, what we have is we've got 22% of the UK's dwelling stock was built after 1980, and around about 78% of it was built beforehand. By where are we? So we're saying around about 2050, that sort of period, roughly 60% of the dwellings that exist will in that future time frame will have been built before 1980. So that's the stock that we can really put a lot of care and attention into. The things built after 1980, in theory at the very least, have got some degree of energy performance associated with them, as we might regard it these days. So if we can retrofit those, great, but the burden of the issue that we'll be talking about really lies in that older stock. So if we refurbished it at 3.5% per annum, then we've got 25 years worth of work to do. And to do that, some fag packet calculations the other day were suggesting that we need a retrofit crew of around about 3.3 million people in the UK. And obviously at the moment, I think we've got around about 135,000 people working concertedly on retrofit. So we've got a long, long way to go in terms of ramping things up. Great opportunity right now for addressing that in terms of getting economies moving again. Another context to recognise is that we've got listed buildings and areas and dwellings in conservation areas. If we extract all of the buildings that are listed and including conservation areas, and the information that I read a while back told me that also that sometimes conservation areas are, how should we say, liberally described in local authorities, so that way they get more funding for conservation officers. So, the actual conservation area itself may not necessarily tally in with the number of dwellings that are actually in conservation areas. But we can say that we've got about 5% of these kind of historically valuable stock, and the rest of it is, we can tear at, shall we say. We've got an awful lot of opportunity there to deal with. As I say, that's 1.2 million buildings. In terms of decarbonisation, then the sensitivity analysis, according to Bob Lowe from UCL, shows us that increased demolition rates aren't really kind of going to help us in terms of reducing carbon emissions, and we've really got to start to focus on the building stock itself. But I'm going to be looking at some of the other reasons why. We also need to think about retrofit. We're going to be looking at health and well-being, energy use, building pathology. We're going to be looking at the climate emergency itself, and we'll touch on timing as well. And I'm going to dig into these grey bullet points in more detail. So health and well-being, we're talking control. A lot of this is all about control for the people in the property, and there are various different perspectives and aspects of control that we need to be giving people so that they can have an appropriate home once it's been retrofitted. In terms of energy use, we're thinking about affordable warmth, and there's also another issue at a national level and arguably regional level as well, in terms of thinking about grid stabilisation. Building pathology, it's all about moisture in our buildings. So I've got a couple of retrofits I'm working on at the moment, which are facing some major challenges, should we say, in terms of moisture. And so there's a lot of work to do in trying to get that corrected before they can really become successful retrofits. And then, of course, we've got the climate emergency in terms of carbon emissions and, should we say, own goals with zero ambition, which I'll come on to later. Okay, health and well-being. So, as I like to think of it, control comes in cans, not can-nots, if you'll forgive the pun. Control, the can, in this scenario, is comfort, air quality, and noise. So when we start to think about comfort, in this context, we've got to recognise that 24,000 to 30,000 people a year, every year, are dying from the cold in the winter, excess deaths, as they get described. So, that's obviously a huge issue right now. And when we start to recognise that and this is somewhat of an old report now, but from the fuel poverty strategy of 2001, but if 5% of our clients from an NHS perspective were saved 10 days inpatient care for illnesses caused by poor heating, the NHS would save £40 million each year, and that would release 150,000 beds. So as we're in a bit of a pandemic right now, then you can put this into the context of, well, flu-related things that can be made worse by the cold, and whether we've got any kind of COVID-related concerns here. Freeing up those 150,000 beds would be really valuable. But another aspect to think about comfort, then we've got to think in terms of, well, how do we do that? What do we need to do? It's not all about providing heat. What we're really talking about is raising the radiant surface temperatures, so the surface temperatures of the walls, floors, ceilings, roofs, etc., so that they're at a sufficiently high temperature. Currently, we might say that our room temperature is being heated to, well, say 23, 24 degrees Celsius to try and compensate for discomfort. That'd be if we were trying to think about it in a comfort model, that's what where we'd end up. Not necessarily everybody can afford that right now, of course, but what it means is that we've got cold, we've got cold surfaces because we've got badly insulated walls, we've got badly insulated windows that may be double glazed, or they've got low surface temperatures. So we feel that on our skin, even through our clothes, and that causes discomfort, which means that we then want to increase the heating to compensate for that. And we're limited by what we can afford to spend. So therefore, we end up with a state of not really quite comfortable, but having to make do with a high bill, or a higher bill than we'd like. And then if we've done a good retrofit, then what we can be thinking about is getting the air temperature down to a reasonable level, because we've raised the surface temperatures. And we've now got a comfortable environment that we can all be living in, feeling comfortable and somewhat more satisfied without those large bills. So when we're talking about the retrofit, we're thinking about it in terms of the impact upon comfort is a key factor here. When we start to put this into a 2050 kind of context and climate, taking into account climate change, then overheating is a major concern. And it's here that the Committee on Climate Change has recognised that already 20% of UK homes, that's 4.5 million homes, overheat in relatively cool summers. So this, by 2050, there's the expectation that 7,000 people a year will be expected to die from the heat. And this is in conditions where, so we say a heat wave is triggered where it's 28 degrees Celsius during the daytime and over 15 degrees Celsius at night. So this is an important issue to recognise. A lot of the retrofit in this particular context is actually going to be some of the 1980s, 1970s and 80s sort of dwelling stock in many respects, with that's been overglazed and built in some very lightweight construction, with some very lightweight construction in one form or another. When we start to think about air quality, so we've done with that's comfort in terms of air quality now. It's worth recognising that we basically inhale 20 kilograms of substances a day, which by weight is more than what we eat and drink combined. Even me on a good day, I can't pack in 20 kilos. So we've really got to think about what's the impact upon our health and well-being in terms of the volatile organic compounds in the rooms that we're in, particulate matter coming in through the windows if we're next to busy urban streets. There's the impact upon health and well-being can be significant. For instance, basically it's reckoned that every 10 seconds someone in the UK is having a potentially life-threatening asthma attack. There are about 5.4 million people currently receiving treatment for asthma. That's about 1 in 10. And 75% of hospital admissions are for asthma are avoidable. And this all comes back down to the, not all, but a good chunk of that comes back down to the quality of our environment in our homes. The statistics show that we've got one of the highest asthma rates in Europe, and we've also got some of the most damp homes. What happens is that basically dust mites enjoy damp old homes, and it's their dust mite feces which can have a significant impact upon people's health and well-being in terms of asthma attacks. So getting humidity under control, getting moisture under control is absolutely fundamental. And again, this goes back to giving something back to the NHS and reducing the burden in that sort of broader context as well. So yes, mold growth, low surface temperatures. This is actually a not too bad example, should we say? But it was a flat that I was living in. Not particularly great. So yeah, just cold surfaces over time. A bit of you tend to see damp spots around windows, underneath windowsills. And when ventilation rates are pretty poor, then there's some pretty shocking photos and examples that you see from time to time. More or less black walls, should we say? But getting the moisture controlled in an appropriate way is really fundamental for our health and well-being. According to ASHRAE 55, then really what we want to be doing is getting the relative humidity somewhere between 30 and 60%. Now, take this graph with a, should we say, a pinch of salt to some extent. It's not absolute, it's a broadly indicative kind of context there. What we can see here is that you've got the viruses petering out and not being an issue technically, as the diagram would say, between 50% and 70%. We know that that's not really quite true, but so it is a diagram. Don't take it too absolute a form, but you can see that there are these broad and generalized sort of relationships that on the lower humidity side, then bacteria can become more of an issue, or we can become more vulnerable to viruses, as we can at higher humidities as well. Dust mites, as I say, favour higher humidities, respiratory infections, rhinitis and asthma kind of issues, chemical reactions increase with temperature and humidity, and then ozone as well. So we've got to get all of this under the control, and we've, as human beings, we've kind of adapted into a niche into this zone, and what we can do is design our dwellings and buildings so that we actually try and provide this kind of level of humidity in a more successful basis, of course. And then we've got the scenario whereby relative humidity is a proxy for good indoor air quality. But it's not always necessarily true. CO2 being a more preferable measure perhaps. But what the research shows is that buildings with trickle vents, their trickle vents get closed. And why do people go and close trickle vents? Well, the experiences, all the measurements and surveys show that basically what's happening is that people feel a cold draft on the back of their neck after that cold air slicks in through the window behind them, and then they close the trickle vent and they never reopen it again, and then the air quality has been destroyed. In effect, all that theoretical ventilation that we're providing from a building regulations context has gone. And you can go into any number of homes, including my own, where the double glazing was installed some years ago before I moved in. There's no trickle vents. How is the house ventilated? What's the humidity like? Well, humidity is pretty atrocious, to tell you the truth. Try to open the windows open, leave them open a snick, but it never really, in the colder winter, you close your windows down again or suffer the scary bills. So the work of Sterling Howison, he observed that basically airtight homes with trickle vents are likely to result in a more toxic and hazardous indoor environment with concurrent and significant impacts on long-term health. And he also identified that the methodology underpinning current regulations cannot be considered creditable. So this is this is pretty damning research, really, and it's very rare that you see in a peer-reviewed journal insidious impact upon public health being kind of touted around, unless it was a strongly held view and evidence-based. Now, this is looking at indoor carbon dioxide I must say, in a new build passive house dwelling, but with MVHR, ventilation heat recovery. But it sets up the frame of discussion, should we say, more than anything else here. So what we can see is we have a total year's worth of data going from 0 hours all the way up to 8,640, I think it is. And then we've got, what we can see here is we've got different classifications of cleanliness of the air, shall we say. Background target levels for carbon dioxide, we would be wanting to be at less than, around about 380 parts per million. And what you can see here is that basically in our passive house, that for 99.5% of the time, we're having acceptable indoor air quality. For about 95% of the time, we've got normal indoor air, what's described as normal indoor air quality. And for a good chunk of the time, 82%, we've got some equally good performance there in 2 different rooms. So good air quality is achievable, and we can get the relative humidities into the right place. And if we're using mechanical ventilation, then it's important to recognise the impact of noise upon people's health and well-being as well. But important to recognise anyway if you're in a busy urban environment. Lack of sleep deprivation can cause major health issues. Now, one of the things to recognise in a home with mechanical ventilation is that the #1 cause of complaints about mechanical ventilation is the noise. And that means that they're not being, many homes are not being designed appropriately. I did a literature review with an acoustician, a friend of mine, Jack Harvey Clark from Apex Acoustics up here in Gateshead, but he works nationally. And basically we did a literature review, we looked at over 1,000 homes, and what was found was most people were complaining about noise, switching off the MVHR or switching it down to a level whereby it was no longer a nuisance. We've found one study, and there's been some other information since then. Well, basically, the key issue is the noise in the bedroom. That's where it's really a problem because people can't sleep. It's too noisy. And what could also be a concern is when it gets too noisy when the MVHR system goes on to boost mode. So little Johnny wakes up at night, goes into the bathroom, switches on the lights, and puts the house into boost mode, and then wakes everybody up. That's not a good news story. So we've got to make sure that we have appropriate acoustic design. The key thing here to recognise is that building regulations hasn't got any requirements for acoustic control for MVHR. It has some recommendations, but we're free to ignore recommendations. And the noise levels that it's looking for actually result in quite high levels of dissatisfaction. So we've got to kind of pay careful attention to getting the right kind of noise levels. I'll talk about more in a little bit.
I'm just going to interrupt. Adam Harper had a question. Adam, do you want to answer that live? Ask the question. Just allowed you to unmute, so you can unmute yourself if you like. If we don't hear from him, I'll just read the question. Okay. Yeah, Adam's asked, is 380 ppm for internal air quality for CO2 correct? Atmospheric CO2 is now over 400 parts per million, so dropping to 380 seems unlikely.
This, 308, basically what you find if you actually monitor CO2, it fluctuates in different pockets. The 380 goes back to the EN standard. It's not, goes back to the European standards. I'm not saying that we wouldn't expect it to be a little bit, somewhat higher these days.
There's another question from Diane. Diane, do you want to ask a question?
Hi, Mark. Can I just ask, the MVHR noise study that you just mentioned, is that publicly available? Is it published anywhere?
Yes. Yes. If you, at the end of the presentation, I'll pull out the paper and I'll put a link in the chat.
Brilliant. Thank you very much indeed.
No problem. Okay, so let me just sort my views out. Okay, so as we start to move on, we'll look at energy use, and in this sort of context, let's think. We've got to recognise that in terms of energy use for buildings, in truth, it's mostly about heat. We've got around about 50% of the energy that we use is for space heating, and then we've got another 20% which is used for domestic hot water. So, there we go, here we are. So yeah, the majority of the carbon emissions that we're talking about in a dwelling are based on the national average dwelling relate to heat. So that's where we've got to really focus the attention for anyone that's not really kind of cottoned onto that yet. And if we get that resolved, then we resolve a whole host of issues at the same time. Now, we can argue that it's actually quite easy to fix compared to some of the more tricky issues, should we say, in terms of food or transport. We can't, you and I as individuals, we can't necessarily fix all the transport issues. We can't fix all the food problems. The transport networks are, our residential environments that we've been building in suburbia and things like that. That we're pretty well locked into those, and we can make some major changes to the dwelling stock. If we look, Okay, I wasn't going to show that slide. I thought I'd hidden that one. I'll skip that. As my license will permit. So basically what we've got is we've got the national grid are looking at what's going to happen with our homes. So at the moment we're using, we've got a scenario whereby there's 606 terawatt hours worth of natural gas going into the grid, and what we have is domestic residential dwellings pulling off 415 of those terawatt hours. In the, that's about now. In the future, the scenario looks quite different. We've got a scenario whereby just 64 terawatt hours will be going into the national grid in one form or another, and the dwelling stock will be using a lot less, and it'll be a lot, because you can see it's also moving from being very heavily reliant upon natural gas to being, to a very, very large extent, reliant upon electricity, and that amount of energy will be reduced as well. So to do, how do we actually achieve that over time? Now, I'm not going to go into all of the finer details on this. The Passivhaus Trust, John Palmer from the Passivhaus Trust has done phenomenal work on this, and there is a whole masterclass on this kind of a related issue. So I'm going to encourage you to go and get involved with that masterclass when it reruns, because that's where you'll learn all about it in so much more detail. But basically, the short summary is the one whereby what we need to do is basically be retrofitting to something akin to Passivhaus standards. And basically bolting air source heat pumps onto our properties is going to create a scenario whereby we don't actually have enough electricity in the national grid to keep our homes heated. So we've got to kind of couple retrofit into that strategy there. But some analysis of my own really highlights the fact that the most cost-effective heat for homes is the energy that we don't use. And therefore, you go back to energy efficiency is the key thing there. So over on the right-hand side, you can see some analysis looking at replacement windows and versus other alternatives. And you can also see a new window for the sake of a new building being quite expensive as well. So trying to do passive solar design isn't cost-effective as a strategy in that particular way. I'm not going to go into this graph in any which great too much detail.
Got a question. Sorry, I just another question from Peter.
Yep.
Peter, if you unmute yourself.
If you could read it out, because I have the children.
Oh.
Would you be able to read? I'm going to get disrupted here. Sorry.
Oh, I'll read the question. So what are your thoughts about slightly lowering the ceilings within dwellings, i.e. less space to heat? Do we really need 8 foot or so high ceilings in rooms?
At the end of the day, that doesn't really make too much of a difference, to be honest, because the heat's going to go out through the walls to the atmosphere. So, your heat loss is basically dictated by the surface area of your building. You might affect a little bit into, you could argue that you're going to tweak ventilation rates a little bit, but in that context. But when you've got a decent ventilation strategy in place, then if you're able to introduce MVHR into that particular scenario, then you're reducing those ventilation heat losses even more considerably. So lowering ceilings I don't see as a major strategy in the long term. Okay, in terms of thinking, happy to discuss that more at the end if you'd like. So building pathology. We've got to, when we retrofit a building, we've got to do quite a lot of diagnostics about the building itself and its current condition. It's not a case of going in and slapping on some insulation and a bit of a heat recovery unit and thinking, right, we've cracked that one. Next site. We've got to really pay some close attention to how we're changing the physics of the building itself and changing its characteristics in ways that aren't always straightforward and aren't always necessarily linear, for want of a way of thinking about it. Building pathology is the methodical study of buildings, their components, the environment, to address failures. So what we tend to be thinking about here is basically rain protection, solar driven reverse diffusion, rising damp, freeze thaw damage, penetrating damp from the rain, all these kind of things that can have an influence. The state of the timbers within the building are the signs of insect infestation, or what do we, when we retrofit, how are we going to change the characteristics of the building in these particular kinds of contexts as well. So there's a lot of subtle thinking in there. I'm not going to say it's an absolute science, and it's something that, to tell you the truth, I think there's a lifetime of learning to go on in this. So the more that we start to gather the data to feed it forwards, the better. And I think this is one of the most valuable sides of retrofit learning that we can do. If I'm honest, if we didn't quite address all the performance gaps in a retrofit for as far as energy goes, I can probably live with that better than knowing that we've created a damp building that is unhealthy to live in, and also is then decaying progressively over the future as well. So we didn't do a good job at preserving it. In terms of thinking about the climate emergency, I think that anybody on this webinar will be kind of quite conscious of the different kind of curves and where we are in the scenarios right now, and addressing the climate emergency and climate crisis. Well, basically, we've got to start acting pretty sharpish, right as in yesterday, and also thinking about what sort of practices, so as an architect, and as an architect that sits on the North East Regional Council, we need to be thinking about the Architecture 2030 Challenge as much as we need to be considering Passivhaus. Passivhaus, of course, addresses these issues, but sometimes addressing things at a at a professional level, should we say, depends on where you are in your journey and the nature of the particular project that you're on. But this is something that we can point clients towards and have concerted discussions about in terms of these trajectories, and what the RIBA also supports us in terms of decision making and being realistic about things. Most of this relates in truth to more geared towards new build, but we could argue that because of the way that it works, the bandings on it, there's also opportunities to consider retrofit potentials in there. When we start to think about cost effectiveness, least cost solutions, this is, I haven't seen any a more up-to-date analysis than this, but this is broadly, this sets out a theory, shall we say. So what we can see is the marginal abatement cost of carbon. We've got negative costs, always nice to see. So something that's saving money is kind of a negative, and things that's costing money in terms of carbon emissions is on the positive here. What we can observe is that if we basically take this area of this kind of triangular shape here, and then we map it over the positive side, we can get a reasonable way, but we've got to make sure that we're doing the energy efficiency measures, which are this lower side here. We've got to apply the energy efficiency measures in order to generate the money that can then allow us to invest, at no additional cost on some of these other things, which isn't to say that we aren't going to need some of the other stuff further over on the right hand side in due course. But starting with the left and moving towards the right is basically the a decent methodology there. I'm not going to go into those curves in too much detail, because as I say, partly because they're old. In terms of timing, well, the old adage of when's the best time to plant a tree, and the answer is 20 years ago. The second best time is now. And the same kind of thing goes with retrofit. In terms of quality, well, then really, as Edward Demings recognised, your quality begins with intent, which is fixed by management, and in this particular context, that means a brief that's fixed with the client. And it's really a case of then, where necessary, appropriately educating clients so they can make informed, intelligent decisions about their properties. So that they're not left leaving things to chance and things being unpredictable, but they're actually getting a predictable result, which is something that people would be a lot more, find a lot more satisfactory And I see Adam Hopp has raised the question of about the carbon abatement cost. Yes, that is in the McKenzie graph, or one of them at least. In terms of retrofit, how do I approach it? Well, the strategy that I've developed is the one of having undertaking what I describe as a retrofit review. And this is, so what I do is I go to site, I do a room by room review, looking at each individual room, assessing what's, whether there are damp issues there, the nature of the room, looking at the strategies. We'll do something with site constraints audit, getting a better understanding of the planning and conservation policy issues associated with the dwelling. Then basically coming up with a report, a retrofit review report, which can then map out the potential for the property. And these things can be done without necessarily looking at doing a full energy cost analysis, shall we say. These are looking at broadly, these are broad strategic impressions. And then we can look at developing what I describe as a vibrant vision action plan, which is really looking at what the skills that will be required to help deliver that project, and the nature of any kind of support that would be required. That often leads, that process often leads on to then a dimensional survey, which allows us to do a more detailed review for, in terms of doing energy modelling, but also allow, so that we can look at construction details and plan out a design in the most appropriate way. Looking at the whole house retrofit strategy and any phasing that might happen. I'll talk a bit more about phasing in a little. If samples need to be taken to be sent off for lab tests because of damp issues and concerned about salts and things, then that can be done. We can look at any in more detail at getting planning permission where necessary, if you're changing the character of a home because you're going to be putting external insulation on, or if it's a building in a conservation area or listed perhaps. And then looking at construction documents. Models, PHPP is the first choice of tools for myself, and then working with Woofy. I was trained in Woofy a few years ago, but I don't actually use it. I'd outsourced that to somebody else. So Woofy lets us understand more about the moisture characteristics of a building and a design, using some more up-to-date standards. It's a dynamic tool rather than some of the old static tools that are available. And then any particular training that might be required for kind of other consultants or designers that I might be working with, or indeed helping trades along the way. So that's basically how there's a bit of a how in terms of how I approach things, but then often working towards standards, and that's part of setting this vision, the quality vision. So basically, key things I would like to touch on today, we've got the EnerPHit standard, and there are two different approaches there. There's the classic and there's the component method. And there's, I'm going to tip my hat, should we say, towards PAS 2035 and the AECB Building Standard and those kind of things, but I'm not going to be getting sucked into too much of those details. And to tell you the truth, PAS 2035 is something that I've got to do an awful lot more learning about myself. So in terms of the headline criteria, there are basically three primary zones of thinking that we need to have in our mind's eye. There's the total indoor environmental quality, there is primary energy and carbon emissions, for one way of putting it, and there's also quality boundary conditions, quality control boundaries as well. So here what we're talking about, we've got space heat. So for the EnerPHit criteria, and this is if you were doing a whole house retrofit, then you would be looking at a space heating demand target of less than 25 kilowatt hours per meter square per annum. So that is roughly the equivalent of 2.5 litres of oil. If you can visualise a litre being 100, 100 by 100 millimeters, 100 by 100 by 100 millimeters, centimeters. Okay, so we've got 1 air change per hour at 50 pascals. We've got summer comfort, getting not exceeding 25 degrees Celsius for more than 10% of the year. Good practice these days we actually regard as not exceeding 5%, to tell you the truth. Making sure that we've got 30 meters cubed per person of fresh air. Noise, you'll recognise that I mentioned noise earlier on. So making sure, Passivhaus does specify noise levels for habitable rooms and not uninhabited rooms. So we've got some noise criteria that we can go to there, and they compare very favourably with the literature review that Jack and I did. And also there's a moisture issue here in terms of making sure that surface temperatures are such that we don't get condensation on the surfaces. Now, this is only about surface moisture, should we say. It's not necessarily looking at some of those other building pathology issues that I was raising earlier on, so that's an important thing to recognise. And then we've got primary energy. Now in PHPP currently, we're talking about 135 kilowatt hours per metre square per annum in the UK. But as our grid's getting cleaner, that will shift around a little bit. And for those that aren't familiar, there's a good nod of respect, should we say, between the building physicists' view of the world, which is primary energy, and carbon emissions. They have a similar correlation until we start to get a particularly clean grid. And then we start to think about things like primary energy renewables, which is another subject matter which I'm not going to be going into. When we think about datums, it's making sure that we've got comparable results. And that's really about having the PHPP, Passivhaus planning package, and it sets out a whole host of boundary conditions that we can then work to and work against and develop trust with and confidence with over time. There's also a component method or an elemental method, if you want to think of it that way, and that means that we don't actually have a space heating demand target. Which might, and the reason for that is we might have a very complicated retrofit, and we're not actually, if it's got a very complicated shape, if it's, we could end up with a scenario whereby to make it hit the space heating demand targets, we'd have ridiculously thick quantities of insulation. So we can do a component-based retrofit whereby we are basically targeting new values for specific walls, floors, roofs, and if we're putting insulation on the inside rather than the outside, then we've got different U values that we'd be looking for to respect some of these moisture issues that we're talking, that we need to also address the building pathology side of things. But otherwise, a lot of these criteria remain pretty much the same. And the primary energy target has also been changed. But there's still recognition of some aspects of energy use because we're thinking about overheating risks as well, and internal gains still need to be factored in. So it all starts to play a part in terms of delivering a very as comfortable a home with using as little energy as possible in a realistic context. So the great thing about Passivhaus in this way is that you've got two flexible approaches that can be used to suit a particular context. So I did a barn conversion, and that worked very well using the EnerPHit Classic approach. But I've got some houses that I'm looking at the moment, which are definitely going to be looking more at the component route as a means of taking forwards the retrofit. And the other thing is, with the component-based method, you've got a lot more flexibility in terms of what you're trying to achieve, and it seems broadly sensible, should we say, and we can do a component-based EnerPHit in a conservation area as much as we could anything else. Principal challenge being windows and conservation officers in that particular regard, should we say. But when we come to, as I say, when we come to the component method, there are some backstop U values that we're talking about. So for external insulation, we've got less than 0.15. For floors, less than 0.19. Internal insulation, we have a U target of less than 0.35. So you can see how these can be quite different for different scenarios. So what we tend to find is if you're using the space heating demand method on interior retrofit, then you might actually end up with space heating demand which could be up as high as 60 kilowatt hours per metre square per annum. But that's a product of the building itself, and that is what it is. Now, one of the key things to recognise is that Passivhaus, and as we heard earlier on, basically, and Harry Paticas will be doing a presentation on his step-by-step retrofit later. We can retrofit buildings bit by bit over time, and the key thing is that we develop a proper retrofit strategy so that we can make sure that the properties are properly insulated as we go, so we're not locking ourselves in it's better if you're going to spend your money, spend all your money on doing the components properly as opposed to basically spreading it around everywhere. And that means that you can then have different steps mapped out as we go. We can have a high level of confidence that Passivhaus is giving us the comfort that we're expecting, the energy performance that we're expecting, because there was a peer-reviewed study that I did with Passivhaus Institute, and that we pulled together data from different passive houses and EnerPHits, and you can see that both the passive houses and the EnerPHit are working, delivering the performance that we'd expect. So we've got the calculated demand along the bottom and the actual delivered consumption on the left-hand side on the axes. And we're generally coming in below that red line or within boundaries of errors. Just to recognise the retrofit coordinator past 2035, and I'll just say that recognises rightly a whole house approach, and there's a lot more coming into the retrofit world on that in due course. And Letty are also working on a retrofit, some retrofit work at the moment. If you're familiar with Letty, the AECB have got the Carbon Light Retrofit training course, and this is currently available, and you can sit that course right now. But we're all, as a trustee of the AECB, we're also looking at upgrading that, and so that's basically you'll be able to become a Carbon Light Retrofit coordinator. So it'll be fully past 2035 compliant. So you'll be able, so if you're not you could be anybody, shall we say, and you could walk in and you could train up, and then you'd be able to be an assessor or an evaluator perhaps. But then a designer, well, that's limited to architects, architectural technologists, and other similar professionals. You're able to then kind of perform a range of different duties to retrofit projects. The AECB Building Standard itself, primarily designed and developed as a new build standard, to be honest. But you could adopt this approach when you're retrofitting if you wanted to go down the space heating demand approach, and you start to achieve the appropriate numbers that we've got here. That's me concluding. If you'd like to, I've got a couple of case studies that have been built out at Passivhaus Secrets. If you'd like to go to that website, if you're interested in getting some Passivhaus training, then go to passivhaustraining.co.uk. If you're interested in the Carbon Light Retrofit course, then go to carbonlight.net. And then as a trustee of the AECB, I'd encourage you to join the AECB to get all the fringe benefits. So there we go. And you can get a free copy of the Passivhaus Plus magazine.
Oh, thank you very much, Mark. So we have about half an hour now for questions. So feel free to put them in the question answer box or raise your hand in the participant box. And we do have a question from Stephen, so I'll just allow him to talk. And if you don't want to talk, I will, I'll speak for you, but I'm just trying to find your name. Here we go. So Stephen, you can unmute if you like. Okay, I will do it for him. You just asked who does your woofie for you, Mark?
It's Toby from Greengage.
Okay. Is there anyone else that would like to ask a question? Don't be shy. Oh, here we go. Got one from Jim.
Hi Mark, thanks for that. Just a quick question. When you're doing a component-based assessment, obviously you do come out with a space heating demand. How do you find the space heating demand compares with the standard?
Sorry, say that again.
So when you're doing a component-based retrofit assessment, it will come out with a space heating demand on your PHPP, won't it?
Yeah.
How does that number compare with the other target? Is it vastly more, or is it the same?
It can vary quite significantly. I've seen it at, as I say, as I mentioned, I think I've seen it at around about 65, 60 in some cases. It really depends on form, the nature of the building, how much internal insulation you're doing, as opposed to external insulation, and the kinds of U values that you get. You know, should we say the constant that you've got is the airtightness that you're looking for and the ventilation rates. Yeah. Does that help?
Yes, yeah, thanks. Yeah, I just wondered whether it produced results that were broadly similar, or as you say,
But as I say, this can be quite,
depends.
yeah, they can be quite different. But that's, you know, that's what it is. But the key thing to recognise in that particular context, I'd say, is that we know that when you're following the right quality assurance methods, which you learn as a passive house designer, then you're closing for those performance gaps. So when you're, you know, so that on average, it's not to say that the HPP is right always, but you know, on a statistically wide group, then with, you know, then the data shows that you know, passive house buildings perform the way that we'd expect them to. So we, you know, that's reassuring for us as professionals and for our clients.
Okay, we've got another question from Florence. Oh, she can't unmute. I'll ask. So if you had a limited budget, say around £35,000, where would you concentrate your efforts to start with?
Which building?
Well, let's pretend it's like a 1937 or a domestic property, say.
Yeah, no, it really depends on what's being done in the property and when. You're always going to be choosing. You know, it's making me think. The question's making me think of a particular project right now. So basically, this is a terraced house. It has, you know, the budget isn't far away from what you're describing there. It hasn't had a new roof on it since it was built, getting on for 100 years ago. You know, it's got some dodgy insulation in the loft. It's going to need a new roof on it anyway, to address moisture issues, to reduce energy use in the first place, and to, you know, to upgrade the roof. So the roof is the right place to start in that scenario. In another dwelling that would be in a better condition, where you would have a better conditioned roof, you know, I'd say something different perhaps.
Okay. We have another question here from Ben, who says, are there any literature or videos you can suggest that would aid in clearly describing passive house to clients with no passive house knowledge?
Passive house retrofit videos. I'm yet to do one. Yeah, get involved with Passive House Secrets. Watch the documentaries that are there, and I'll update you when I've done the retrofit one. Yeah, there's nothing. There's nothing quite so succinct at the moment that I know of in video terms at the moment.
Okay. So we've got another few questions here. I don't know if Vasilis, I hope I've said your name correctly, if you'd like to ask your question live.
Yes, thank you very much. My question is, you've just answered actually that one a few minutes ago. If we go actually certifying a retrofit project using the components criteria method, don't the thermal bridges affect a lot, perhaps the thermal comfort on some components due to higher thermal bridges? I mean, the EnerPHit standard doesn't have any criteria for thermal bridges, doesn't actually limit the thermal bridges. First of all, is that correct? And the second thing is how that one affects the thermal comfort on some specific components. That was the question.
Okay, so well, in any passive house, you've got to account for thermal bridges, should we say? You know, in a new build passive house, because of the way that the passive house standard works, we'd say that a new build would achieve 0 thermal bridging. In a retrofit scenario, we would expect some positive thermal bridges, you know, that we might not be able to address because they're structural thermal bridges, for instance, and that is what it is. And if we, in an elemental context, then what we're really wanting to do is basically make sure that we're addressing the FRSI issue, in terms of making sure that we're avoiding moisture risks, and therefore, so we're not going to get surface mold growth and those kind of problems arising, which means that we do have to have a suitable level of continuity of the insulation, though it's not absolute for the way of describing things. And in that context, what that would mean when you start to think about the discomfort you were concerned about, you've raised surface temperatures to a reasonable degree to avoid cool down drafts. So I don't see that there's a particular problem in terms of thermal comfort. So if you're thinking about components like windows, for instance, a subject I think that's quite close to your heart, then what we're talking, then we're not saying that we've ruined that, the kind of whole window U value necessarily. We can still think about that carefully and thoughtfully. You're muted, Anika.
My apologies. We've got another question from Christopher.
Hello there. Great. So I understand, your focus, Mark, was on standards in terms of U values and, sorry about the background noise, but U values and air change targets and so on. I'm just wondering if there are kind of standards or official standards for specific methods, such as suspended floor insulation, because I just seem to see differing opinions between experts on whether membrane should be permeable, vapor permeable or not, whether material should be hygroscopic or not, and so on. Where would be the place to go to get kind of the best in class official standard on how to do that?
I think the best place to get information about good quality design for retrofit, the best one that I know, I should say, there may be better places out there, but the best one that I know is certainly the Carbon Light retrofit course, so carbonlight.net. That goes into a lot of detail in terms of looking at moisture issues and the likes. And if you're a member of the AECB, then there are some webinars that have been done which talk about some of the issues that are in that course as well. Retrofits. In fact, some of the Harry's retrofits is discussed in there. But there's no, in terms of thinking about, it's still, in terms of looking at absolute answers, there aren't any. So if we take the floor example that you gave, there's some great research that's been done by an architect researcher, Sophie Pelsmaker, and her PhD looked at floor U values, but she's done some very good, very interesting peer-reviewed papers looking at moisture in floors as well. And that was looking at retrofitting the floor in place, should we say, and leaving the air gap underneath. And do you cork up the air bricks or not? And what are the issues? And there's the conclusion. The broad general conclusion was, if you're going to keep the suspended floor, don't block up the air gaps, because there might be something beneficial from that. But there are other moisture consequences to doing that as well. I come down in favour of removing the ground floor timber if you can, and replacing it with a different kind of floor. But you've got to be mindful of other moisture issues when you do that. So it's, there's no absolutes, unfortunately. It's a case of you've got to judge each individual instance on its own merits.
Great, thank you.
Does anyone else there's no questions at the moment. Does anyone else have a question they'd like to ask?
I'm just going to, Diane asked that question earlier on, didn't she?
Yeah.
I'm just going to see if I can pull up one of the versions of the paper that I did with Jack.
I've got a question actually. I'll wait till you finish doing that. Oh. Shall I ask it?
Yeah.
So your comment about timings, we needed to have started yesterday, but we've got to start today. Like, I obviously absolutely agree. In Manchester, often we have a sort of, I've heard quite a few times, sort of looking at the carbon budget, you know, Manchester needs to retrofit 61,000 homes this year.
Yep.
And when I hear that, I think, well, we don't have the supply chain to do that. And actually, if people in the local authority positions rush towards trying to achieve that badly, it's almost worse. So I don't know if you have any thoughts on, like, how do we move as fast as we can in a way that is of good quality that actually meets the targets that we need to meet?
Yeah, well,
So
we need
it's a hard question, but I never know quite what to say to people in sort of positions of power in the local government when they say things like that. I'm kind of like, whoa, well, I'm not sure that's such a good idea that you have those kind of figures in your head, because you might just lead you down the track of, you know,
I think
external installation everywhere.
Yeah, and I give mind to these kind of thoughts every now and again, but I'm not going to say that I haven't got the answer. I've just got some reflections of thinking about it for a while. And having been dealing with Passivhaus for 14 years now, it's the same kind of thing. I think that we can look at what other countries have done. I can't think of any examples in terms of retrofit specifically, but if we look at what's happened in Belgium with Passivhaus, for instance, they actually what happened there was a scenario where they recognised that they needed to do something different to what they were doing. So they then started to introduce a grant and said, look, we're going to support people that want to do new buildings in that particular case, but you could equally say that it could work for retrofit. We're going to support what happens the most. We'll learn from those from those projects, and then what you see is, oh, hang on a minute, a lot of people are doing Passivhaus retrofit. That's interesting. Maybe that's where we need to put our money then, because they've judged the marketplace and they've seen that the marketplace is doing something, and then they know what they need to get behind. And once they know what they need to get behind, they say, how do we scale that up? And then, well, that's training, because that's part of the process that the funding that we're providing before was training to enable something to happen. Should we say? So I think that we could mirror some of what happened in Belgium with Passivhaus new build. You could mirror the same kind of thing with an EnerPHit approach, or just looking at retrofit as a strategy and seeing what comes to the surface. And if there are standards that are useful to people, we should then rally behind that. But it's an exponential curve as well. They started off with very few passive houses, and then it eventually became policy that everything had to be Passivhaus since 2016. That magic year that never came in the UK. And then so basically you've got that one whereby you'd be able to educate and kind of and ramp up over time, so that it's not really 3% per annum. It's kind of like 0.01% this year, but sort of 15% in the final year, because we've got the knowledge, the skills, and we've got that momentum. The question then, of course, is once you've done that, what happens with all the people's jobs after that point? You've kind of gone off a cliff. But we'll worry about that one when we get there.
Yeah.
I think dealing with that economic impact is probably easier and more preferable to the climate issues that we're facing right now.
Thanks for that. Actually, kind of in a similar vein, we've got a question from Diane here.
I think you've just answered it, Mark. My question was, if you had £2 billion to spend before March 31st, what would you do? And I think you've just answered it.
I would educate. I would browbeat everybody in a nice kind of way.
Okay, so we've got another 2 questions here, so I'm just inviting them to speak. Adam Harper.
Hi, Mark. Can you hear me okay?
I can indeed.
I don't know if you've been following the Green Homes grant, but I wondered if you had any thoughts on whether it's likely to complement a whole house approach, or whether you think it might lead to what you described early on in your presentation as a more sort of ad hoc approach of people just installing single installation measures.
Yeah. I haven't had a chance to get into it in any great detail, to tell you the truth, but yes, that is my underlying concern, that we would end up with a fragmented approach, that we would basically waste millions of pounds because we put in little bits of fluff as opposed to doing it properly and to the proper quality. And then you never mind everybody else running on the gravy train kind of idea and you know, just trying to make a bit of fast cash. You know, we need to make sure it's all backed up with quality. I've much, yeah, it makes me think of it's the same kind of approach to the one that we use with green deals for, you know, with renewables, feed-in tariffs. We seem to always get it wrong in the UK. What we do is we start off with we're going to give you £1 per kilowatt hour, you know, some sort of crazy number. And then what happens is all of a sudden you get this boom and bust scenario going on because all the funding ran out again, as opposed to gradually ramping up the amount of funding over time for specific projects in such a way that it creates a more sustainable economic scenario that can enable people to do things. And you avoid the boom and bust, and you can also control and throttle the rate at which education and growth is happening, so you can direct it in a more thoughtful and concerted fashion. So that's something else that I'd like to, you know, another one of those paradoxes that I've not quite understood yet or addressed.
Okay. Thanks, Adam, for the question. Ben has got another question. I'd like to speak. Or I could read it for him. Do you find the desire for low energy deep retrofit to be in certain regions of the UK? So are there sort of like hotspots of interest in deep retrofit?
There may be. I can't say that. Yeah, I tend to work in the northeast, so I'm going to say that I'm quite insular in that respect. I don't know how other places always look hotter, put it that way. You know, the north, but part of that's down to population densities as much as anything else. You've got, you know, the northwest of England's got, you know, very major conurbations. The northeast doesn't have the same density of population. So yeah, but there are you know, you do see occasional hotbeds. There are some hotbeds, Manchester, you know, because of everything that carbon co-ops do. Really, I think is a key thing there.
Yeah, I think as similar places like Bristol and other parts of the UK where they've got sort of organisations really promoting this, parts of the southwest. So no, it definitely helps. There's a question here from Peter.
Yeah, hi Mark. Thanks for the presentation. Great. Just a quick question on the subject of noise. I've noticed you've put up some figures there to do with the Passivhaus standard being 25 dBA, which seems incredibly quiet. I know ADF has an advisory of sort of 30 dBA in bedrooms and 35 elsewhere. Just interested to know if it's part of the Passivhaus process to test noise internally, and whether that's noise from outside coming in or whether it includes sort of internal mechanical noise from ventilation systems and other such things.
Okay, so the 25 dBA is looking at your MVHR system itself. You know, it's not a case. You know, what you find is, you know, with Passivhaus new builds, I'll just put it in that context for a moment. With a Passivhaus new build, because it's so much more airtight and you've got the insulation and everything else that's going on, they are more acoustically isolated from the outside anyway. And the same would go with a Passivhaus retrofit. You know, you've improved the airtightness, you've got better insulation in there, you've improved its performance acoustically in terms of having better control. But that's not a specific target, you know, in terms of that level of isolation from the outside. That's not something that Passivhaus is trying to achieve. It just comes with it from good standards of airtightness and things. The 25 dBA is really targeted around stopping noise from the MVHR system getting into habitable spaces. Yeah, I agree that the building regulations numbers are much higher. There's a slide that I didn't put into this particular presentation But basically what you get to is about 1 in 3 people will be annoyed by the noise levels of building regulations recommended performance. I should hasten to say that most people don't, and I've been into what was a code level 6 home in the middle of the winter and the windows were open, and it struck me a bit strange. So when I did switch on the MVHR system, I was a bit shocked when the floor started shaking. That was in Oldham. Some of those in Manchester could go and visit it if you wanted to. But yeah, so there's quite shocking differences between how you commission an MVHR system for a Passivhaus certified building versus a building regulations building. The building regulations, you go in, you flick a few switches, you walk out within an hour. Whereas with a Passivhaus building, it'll take about half a day, maybe a bit longer, to balance the MVHR system and get it working sweetly to deliver the air to the relevant rooms, and the checks are done to make sure that it's not too noisy as well.
Yeah, thanks. I was just going to add, I think 90% of the failures I see in ventilation systems is absolutely down to noise, and I think Jack Harvey Clark shares our frustrations that it's not part of a sort of testing procedure when we come to commission ventilation systems as well. But it's good to see that it's done in Passivhaus. I think that's really encouraging. And
I think to be clear, whether it's people do take sound, certifiers do look, at least some certifiers do look for some acoustic measurements, but we're not doing it to what I would describe as an acoustician standard, because it's not using the same high. They don't reach the bottom end in quite the same way, so there's internal noise issues that can come from some of the readings, but it lets us have an idea about how things are performing. What it is worth noting is that Jack did go back to some of the racecourse Passivhouses that I'd worked on, and he did measurements in situ, and we found that most of the time we were satisfying the performance requirements. When that wasn't the case, it was because because there were other incidents of noise, namely somebody mowing the lawn or some vehicle driving by or something else that we could identify. Suffice to say, once the crosstalk attenuation was in, and the main attenuators coming off the fans were in there, you're not really going to get the noise issues. So it's more one of, if you can do a visual assessment at the right time and see that the attenuators have gone in, then in all likelihood it'll work because the design work has been done in the first place.
Okay, does that answer your question, Peter?
yeah, absolutely. Thanks very much.
We've got an interesting question from Amar about investors and the value of retrofit. I don't know if you want to ask it yourself, Amar. You can unmute if you'd like to. Okay, I'll ask the question. So I work with some investors who do refurbs and encourage them to improve the energy efficiency of their properties. Many are concerned that if the money that is put towards energy would give a corresponding increase in the value of their properties. Do you have any information about this?
Yeah, this is always the ideal, shall we say? No, I've never come across any. I've looked at a lot of research papers and tried to find answers to this question myself, because wouldn't it be wonderful if we could say to our clients that when you insulate your property and its value goes up? Unfortunately, it's not true. It's not to say that it can't happen. It's just that it doesn't happen. People place priority on where's your house? It's nearer the school. That's more valuable because energy is not the thing that's going to add the value in that particular context. But that's not to say that things it can't be beneficial. So if you can say that your house has been retrofitted to a standard as opposed to just we put some insulation in, that over time has a better perceived value, and that perception of value. And this is where we start to get into some of those kind of softer areas of economics, whereby, well, you can't measure it in pounds, shillings, and pence, but the house sold a lot faster. And if the house sold faster, that has economic value to it as well. So there's different, there's subtleties to things, which I'm not going to say that I'm an expert in, but that you read about every now and again and your mind churns over. And yeah, it's just hard to quantify, and it's subtle. But those that there are sort of implicit values, economic values, rather than anything explicit.
And I've also thought about this quite often and wondered whether, as the values of society change, things that people will pay for will change. And at the moment, it won't necessarily add value. But there is a potential that as there's sort of greater awareness around climate change, and there's also greater understanding of how nice it is to live in a warm, comfortable home without damp, that will start to become valued.
I think that one of the things that we're starting to see in a commercial context is where people, that people are buying decisions, should we say, in terms of where they rent accommodation, rent offices, by pre-COVID at least, and that they were looking for more energy efficient buildings, and there was a whole host of different factors associated with that. There was a book that I Retrofit for Purpose. I did a chapter in that for with Sunan Prasad, ex-chair of the RIBA. That's looked at some of the things that are going on in the States in terms of how they're developing economic models for commercial buildings. So might be something to have a little look at and a read through. You're muted again, Anika.
There's one more question from Ben, and then if anyone has a final question after this one, because we're approaching 7:30, get it in now. Otherwise, we will wrap up. So Ben, would you like to ask a question? Well, I'll ask it for him. Are there any documents you can recommend that are directly aimed at IWI? So I think this is again about looking for sort of guidance standards around different parts of insulation.
Are there any documents? There are documents. Sadly, I can't recommend them because they're all bad, I think is the summary. No, you've got, I wish there were some good documents on IWI. They tend, at the minute, they don't exist. There used to be different. I don't know whether you've seen anything, but I've never come across anything.
I mean, it's a part of the issue is that every house is different and the context is different. So if you start having standardized guidance, this is just what I've seemed to have understood. I don't come from a building professional background, but if you have standardized documents, it's kind of dangerous because people might apply them in a blanket way and not necessarily deal with the context of which you're installing that particular measure.
Yeah, I think that, yes, I've not seen good guidance, should we say. What you've just given is an example of how good guidance could be written that would be contextualized. It's not, we need more information about how to do IWI properly and safely for a whole host, for health and well-being reasons, as much as for moisture reasons and reducing carbon emissions, the whole works. There's no good documentation on it that I'm aware of at this particular point. There's a lot of reading I could always try and do, but yeah.
I mean, again, a part of what we see in Carbon Corp is often the client will have ideas about what kind of material they want to use, which will then affect the kind of guidance. So some will be really interested in more ecological embodied carbon type measures. Others won't be so interested in that, and then the guidance will be different. So again, it's also if you take a person-centered approach, it's hard to have these sort of standards and some, not standards, but standardized.
Yeah. Yes, I think the area where I tend to think about things is you've got to start from moisture. Right. When you're dealing with IWI, certainly that's the first thing to be dealing with, and it does. I don't care. Should we say what the client wants in that particular context? It's a case of we've got to make sure what's appropriate for the building, and we'll help them make informed, intelligent decisions, which may help them deliver, work along the lines that they were thinking, or we might move radically distant from that. But it's making, it's what we can do as professionals is help people make informed, intelligent decisions. That's what because we're immersed in this so much more frequently than anybody else. We can, we've got the opportunity to be that helping hand, because it can be overwhelming. I think that in this internet age, we can get all the information we ever want. And I read a lot of my peer-reviewed journals because they're available on the internet. as PDFs. You know, it's not because I'm always subscribed to stuff like that. So you know, it's actually deciphering it and making it so that and helping people make those decisions. And that's where our value can start to really creep in. And
yeah, exactly. Two cheeky questions have come in at the last minute. Are you happy to take them? We asked a little bit of time. If anyone needs to leave, obviously do leave. And we've had a few comments in the chat box saying thanks very much for a great session, Mark. Let's go to Chris. And then these will be definitely the final two questions, and then we'll wrap up. But would you like to ask your question, Chris? Chris has unmuted, but we can't hear him. Okay, I'll ask his question. So as a part 2 architectural assistant looking to get more clued up on retrofit, would you recommend a course like Carbon Light Retrofit, I'm assuming he means, or are there more? Absolutely.
Yeah, there are. Yeah, if I remove for a moment my my bias as a trustee of the AECB, which is a not-for-profit, by the way. So I earn no money even though I give my time. So it's basically, yeah, you've got Carbon Light. There is the Retrofit Academy, and I think they are doing some past 2035 training. But I do know what's inside the Carbon Light retrofit course, and it's very good and it's very robust, and it looks at all the moisture issues which I keep flagging up. So I definitely say that that's a good one to start with, and other ones will be complementary to that. I don't think other courses go into quite the same level of detail as the Carbon Light Retrofit when we're talking about some of these deeper issues. So, the other courses might be a little bit more general, but I haven't seen inside them, so I might be treating them very unfairly. There are, at this particular point, as I did mention, the Carbon Light Retrofit course does need an upgrade to make sure that you can get a past 2035 qualification out of it. So there are differences between the two, but those gaps can be and will be closed.
Okay, thanks.
I just wanted to say as well, I've done the Carbon Light course and it is very, very good. Although, like Mark, I need to take my AECB hat off for a moment in saying so. But yeah, it's a really worthwhile course to do.
And Bruce, the final question, if you'd like to ask it. I'll ask it from, I don't fully understand this question, but if a house has insulation as a part of a timber kit, how would you improve the insulation to the walls? I don't fully understand that.
So this makes me think, and the nature of the question, if nothing else, makes me think of it's a timber frame retrofit. How do you do a timber frame retrofit? And yeah, there's swings and roundabouts to that, I think. I haven't actually done it. It depends on whether the building is clad in brick or whether it's got a timber rain screen. If you're in the USA style scenario, then you can do what they describe as a chainsaw retrofit, and you can take the rain screen off and insulate back from the outsides. But if you've got masonry there already, which often we see in the UK, and I'm trusting that this isn't a kind of 13th century listed building, then I know that, well, S. Trisida, he's doing a retrofit. He's a certified Passivhaus consultant up in Fort William, that direction, and he's doing a timber frame retrofit because that's a big issue up in Scotland. I think he's doing a little bit of a hybrid approach with some internal insulation. But yeah, it's tricky, and it requires some careful work in terms of opening it up. Perhaps you're looking at removing insulation, removing internal plasterboard, removing the old insulation, which may be near useless, and then building things up from the inside.
Okay, thank you very, very much, Mark, for giving us your time, and yeah, it was a really, really interesting session.
My pleasure to have helped.
Just a quick thing to say that our next session will be on introduction to our home energy planner. I think I put it in the chat box as a hope retrofit planner. So yeah, let's hope that we get a home retrofit planner session at the end of September. But if you'd like to look at that, go ahead. And yeah, any feedback to us in the chat box is welcome. But yeah, we'll leave it there. Thanks again, Mark.
No problem, my pleasure, my pleasure. I hope everyone got a lot of benefit from it.
No, it seems like we've had lots of positive comments in the chat box.